So, we have the equation a plus 3 equals a minus 3. And before we jump into solving this fascinating little problem, I would really appreciate it if you could hit that like button and subscribe to the channel, because it helps us reach more students who want to master math just like you are doing right now. Now, looking at this problem, you might be thinking it looks incredibly simple, and in many ways it is. But it is also a perfect trap that catches so many students off guard, especially on exams, because it challenges your fundamental understanding of what an equation actually represents. We're going to tackle this using two different methods, and the first method is what I like to call the brute force algebra method, where we assume there is a solution and we try to find it by expanding everything. So let's get started with method 1, where we're going to square both sides of the equation to eliminate any potential sign issues and see what happens algebraically. So we take the left-hand side, which is a plus 3, and we wrap it in parentheses and square the whole thing. And then we do the exact same thing to the right-hand side, taking a minus 3, wrapping it in parentheses and squaring it. So now our equation looks like the quantity a plus 3 squared is equal to the quantity a minus 3 squared. Now, to expand this properly, we need to remember our classic algebraic identities, specifically the square of a binomial sum and the square of a binomial difference. So remember that x plus y all squared is equal to x squared plus 2 times x times y plus y squared. And similarly, x minus y all squared is equal to x squared minus 2 times x times y plus y squared. This is a great moment to pause and make sure you're comfortable with those formulas, because we're about to apply them right now. On the left side, applying the formula gives us a squared plus 2 multiplied by a multiplied by 3 plus 3 squared. And on the right side, we get a squared minus 2 multiplied by a multiplied by 3 plus 3 squared. Now let's simplify these terms step by step. So on the left, 2 times a times 3 becomes 6a, and 3 squared becomes 9. So we have a squared plus 6a plus 9. And on the right side, negative 2 times a times 3 becomes negative 6a, and 3 squared is 9, giving us a squared minus 6a plus 9. Now we have a big equation. A squared plus 6a plus 9 equals a squared minus 6a plus 9. And we want to group our like terms. So watch carefully what happens here when we try to collect everything. If we subtract a squared from both sides, the a squared terms completely vanish, which is interesting. And if we subtract 9 from both sides, the 9s also cancel out completely. And suddenly, we're left with something much simpler, which is 6a equals negative 6a. Now, a lot of students get stuck here, but we just need to get the variable a by itself. So let's add 6a to both sides to move that negative term over from the right to the left. And that gives us 12a equals 0. Now, this looks solvable, right? Because if 12 times some number a is equal to 0, then by dividing both sides by 12, we find that a must be equal to 0. So you might be tempted to box that answer and walk away thinking you solved it. But hold on a second, because this is where the trap is, and this is why checking your work is the most important part of algebra. We found that a is 0. But does that value actually work in the original problem? Let's verify it by plugging 0 back into our very first equation. So on the left side, we substitute 0 for a, which gives us 0 plus 3. And on the right side, we substitute 0 for a, which gives us 0 minus 3. Simplify that, and you get 3 is equal to negative 3. Now ask yourself, is 3 ever equal to negative 3 in our real number system? Absolutely not. It is impossible, because 3 is a positive value, and negative 3 is a debt, so they cannot be the same thing, which means the statement is false. This tells us that the answer, a equals 0, is what we call an extraneous root, which is basically a fake solution that appeared because we squared things, but it does not actually satisfy the original question. So, method 1 shows us there is a big contradiction here. Now let's look at method 2, which is the faster logic-based method. And if you used this, you probably saw the answer immediately. Let's go back to the start with a plus 3 equals a minus 3. And instead of squaring, let's just try to group the a terms together by subtracting a from both sides of the equation. When you do that, the a on the left minus the a you subtracted becomes 0, and the a on the right minus the a you subtracted also becomes 0. So the variables completely disappear from the universe of this problem, and you are left with the statement 3 equals negative 3. Again, we have arrived at a mathematical impossibility, simply meaning that no matter what number you put in for a, whether it is 1,000,000 or -5 or 0, you will never ever make this equation true, because a number plus 3 can never equal that same number minus 3. It just doesn't make logical sense. So, the final confident answer here is that there is no solution to this equation, or we can say the solution set is empty. I hope that clears up why we sometimes get fake answers and why logic is your best friend in math. So please make sure to hit that like button if you enjoyed this explanation, subscribe for more daily math lessons, and if you have any doubts or if you solved it a different way, please write them down in the comments below because I love reading your ideas. Class dismissed.